Assalamualaikum warahmatullahi wabarakatuh. Now we will go through the first question, which is convert transfer function to standard format of transfer function to get a dot plot. First, we must factorize 2 and 10, and it will become 2 times 5 open bracket 1 plus g omega over 2 over 10 g omega open bracket 1 plus g omega over 10. So this is a general standard of transfer function equal 1 plus j omega over 2 over j omega open bracket 1 plus j omega over 10. So this is a 0, this is a pole, and this one is a simple pole. So magnetic plot hash decay equal to 20 log 1 plus j omega over 2 minus 20 log 1 plus 1 over j omega minus 20 log 1 plus j omega over 10 minus refer to bottom equation. First plot, the angle is equal to tangent omega over 2 minus 90 minus tangent omega over 10. Minus 90 is refer to this. Therefore, magnetic plot is 1 0 z equal to 2, 1 simple pole p equal to 10, and 1 pole 1 over j omega. The z divided by 10 is 0.2, this one, and p divided by 10 is 1, this one. This is how we plot the graph. For magnetic plot, we will make dot line for our guided line before we proceed to make a line of dot plot. So 220 log 1 plus j omega over 2, and this one is 20 log 1 over 1 plus j omega over 10, and lastly 20 log 1 over j omega. This is for decade, okay? Next, for phase plot is the dot line is for negative 90, this one, and another dot line is tangent up omega over 2 and negative tangent omega over 10. So we can make the line here and lastly here. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. So now I will explain how to derive transfer function from dot plot. So here we have a transfer function. So the first thing is we need to know the gain. So to know the gain, we will check at the origin here, and we see that there's an inclination. So when there's an inclination or declination, which means that there are 0 at origin or pole at origin. So since it is plus 20 dB, it is an incline. It means that there is a origin. There's a 0 at origin here. So 0 at origin, it shows that it is supposed to be negative 20. So the difference here is plus 20 dB, because the transfer function that we got, the dot plot that we got, the graph is at 0. So the difference is 20 dB. So we will calculate k, and the formula for k is 20 log k, and the gain equals to 20. We will get k equals to 10. So second, we will look at all the corner frequency. We got 1 at origin here, we got a corner frequency here, and we got a corner frequency here. So the first corner frequency at omega is 0.1. We will get plus 20 dB because the incline is plus 20 dB. So plus 20 dB, it is a 0 at origin, just like we said just now. And the formula for 0 at origin is j omega. Okay, so now at the second corner frequency, which is at 2, omega equals to 2. So at omega equals to 2, it is minus 20 dB. Why? Because the changes here from positive 20 decibel into 0. So from positive 20 to 0, we will minus 20. That is how we get 0, right? So which means that this is the declination for the second frequency, corner frequency. So at omega equals to 2, it is minus 20 dB. and any corner frequency other than at the origin is either a simple pole or simple zero. If it is positive, it is a simple zero, but if it's a negative here, it is a simple pole. So this is the formula of the simple pole, with the j omega divided by 2. The 2 here is the omega, so that's the difference. Okay, so at the third corner frequency, you have omega equals to 10. So omega equals to 10, it is a minus 20 decibel, because from 10 decibel per decade, it changes into a negative 20 decibel per decade, which means that from 0 here, we will minus another 20 to get negative 20 decibel per decade. Okay, so it's a minus 20 decibel, simple pole again, and the formula is the same, but j omega divided by 10, which is divided by the omega, the corner frequency. So now we will write the k here, all this formula here, into a transfer function, and we will calculate it so that the j omega is not equals, will not divide by any number, we will divide by 1. So we will calculate it, and this is the transfer function we get. Okay, so that is how we derive a transfer function from a bode plot. So thank you, that is all from me.